In this video, I'm going to discuss about WURTZ reaction. WURTZ reaction is a named reaction which is used to synthesize alkanes. In this reaction, alkyl halides react with the sodium metal in presence of dry ether as the solvent to get an alkane and sodium halide as the byproduct. So here Rx is the alkyl halide. So the alkyl halide reacts with sodium in presence of dry ether as the solvent to get an alkane and sodium halide as the byproduct. Using this reaction, we can prepare only symmetrical alkanes. So that is, if you cut in the middle of the molecule, then we get two identical halves. So let us look at the reaction taking an example of methyl bromide. So if you react methyl bromide with sodium metal in presence of dry ether as the solvent, then we are going to get ethane as the product. So if you look at the reaction, the starting material has got one carbon atom and in the product we get two carbon atoms. So that is, in this reaction, we always get the product which has double the number of carbon atoms when compared to the starting material. So in order to predict the product in an easy way, so we have to write one of the alkyl halide as shown here and the other alkyl halide with BrCH3 as shown here, and then remove this sodium bromide, keep a bond between this CH3 and this CH3. Then we get the product. So let us look at the reaction with ethyl bromide as the starting material. So if you take ethyl bromide and react it with sodium and dry ether, then we are going to get butane as the product. So that is, here we have two carbon atoms and in the product we are going to get 4 carbon atoms. So that is, always we get the alkane with double the number of carbon atoms. Like in methyl bromide, there is only 1 carbon atom and the product has got 2 carbon atoms. And ethyl bromide, there are 2 carbon atoms and we are going to get 4 carbon atoms. And in this reaction, we should maintain the dry conditions. That is, we always use dry ether because the moisture will react with the sodium metal violently. And the mechanism goes via the free radical mechanism. And this reaction is not used to prepare methane because methane has got only 1 carbon atom and therefore we cannot prepare methane by this reaction. So the first member that we can prepare is ethane. And let us look at how we can say the starting material when the product is given. In organic chemistry, we should be able to answer the starting material when the product is given. And when starting materials are given, we should be able to tell the products. So let us look at how we can tell the starting material when the product is given. So here the product that is formed in this reaction is butane. So what will be the starting material to prepare butane? So simply is we have to cut the molecule at the middle. That is, using this reaction, we can prepare only symmetrical alkane. So we have to cut at the middle and then put a bromide. Then we get the corresponding alkyl halide. So if you cut butane at the middle, you have 2 carbon atoms and then attach a bromine, that will be ethyl bromide. So the starting material used is ethyl bromide. And next is 2,3-dimethyl butane. So again, since we can prepare only symmetrical alkanes, just break this bond in the middle of the molecule and then attach any halogen and you can just say the product. That is, isopropyl bromide is the starting material to prepare 2,3-dimethyl bromide.